So in this session, I'll take up one more problem on relative velocity in which the flow velocity of river is not uniform. In the previous session also I discussed one problem on this non-uniform flow velocity. In this also I'll take up one more question on riverman problem in which the flow velocity of river is not uniform. It in general varies from location to location. Fine. So first I'll write down the question. A straight river of width 2L flows towards east. The flow velocity is 0 everywhere on the south bank. The flow velocity is 0 everywhere on the south bank. The flow velocity is 0 everywhere on the south bank and increases linearly the distance y from the south bank increases linearly with distance y from the south bank to a maximum value of at the center. And then linearly decreases with distance y from south bank to a value of 0 everywhere on north bank. Fine. S is a swimmer whose swimming speed in contact with any river particle with respect to any river particle in contact, a river particle in contact is U. The swimmer at point on the south bank taken to be the origin and positive x-axis along eastward direction. Positive x-axis along eastward direction and positive y-axis along northern direction. I love this one, okay? I'll take this also, I'll rub it, okay? The swimmer swims across the river such that his heading is towards north. His heading is towards north. Okay. Now what you have to find, what you have to find. Find first the Cartesian equation of find first the expression for river flow velocity as a function of distance y from southern bank. Expression for velocity of river particle. Velocity of river particle. The expression for velocity of river particle as a function of distance y from south bank. Second thing, you have to find a time taken by swimmer to cross the river. By swimmer to cross the river. Third, you have to find the drift of the swimmer while crossing the river. Drift of the swimmer while crossing the river. Okay, so these three things we have to evaluate. Fine. What I'll do to solve the problem, the solution of this problem, I draw the top view of the diagram, top view of the situation. So this is the river C, top view of the river. 2L is the width of the river. This is the south bank, this is the northern bank. This is the point 2 on the south bank, starting point of swimmer, taken to the origin of the coordinate system. Positive x-axis is along eastward direction. Positive y-axis is along northern direction. Okay, fine. Now, what we have to first, we have been told to find the expression for river flow velocity. Velocity of river particle as a function of distance y from the south bank. Okay, so that I'll do first. Now, let us VRG mean VRG, velocity of river particle at a distance y from the south bank. This we have to determine this function. Now it is given that the flow velocity of river is 0 everywhere on the south bank and increases linearly with distance y from south bank to maximum value of u at the center of the river. And then again it decreases linearly from u to 0 to everywhere on the northern bank of the river. Okay, fine. Now I'll rub this one, okay. So there will be two expressions for VRG. First for first half of river and second half, two expressions. So two expressions for VRG. So we take case 1. Case 1, we take case 1. Case 1. Y lying between 0 to L by 2. Alright. Now it is given that VRG varies linearly with y. So VRG is a linear function of y. So VRG should be of this form. K1y plus K2, where K1, K2 are constants to be determined. And y varying between 0 to L by 2. So 0 to L, sorry. Because width is 2L, so y between 0 to L. First half of the river. Okay. So now to determine K1 and K2. At south bank, everywhere flow velocity is 0. At south bank, y is 0. Y is 0, VRG 0. So when y is 0 implies VRG is also 0. So y 0, VRG 0. This means K1 0 plus K2. So this means K2 is equal to 0. Fine. K2 is equal to 0. So K2 goes away. Now how to find K1? At the center of the river, flow velocity is how much? U. At the center, y coordinate will be how much? L. So when y is L, VRG is U. When y is L, imply with that VRG is U. So K2 is 0 and YL, VRG is U. K1 L plus 0. K2 is 0, so K1 becomes U by L. Alright. K1 is equal to how much? K1 equals to U by L. So first half we have obtained the function. For first half of the river, first half portion of the river, VRG will be equal to Uy by L. When y varies from where to where? 0 to L, then VRG varies in this way. First half we have determined. Alright. I'll drop this one also. Fine. Now for second half, y varies from L by 2 L to 2L, and for that again VRG again decreases linearly y. Okay, so for second half of the river, that is y varying from where to where? L to 2L. Again VRG is a linear function of y, so we'll write VRG as K3y plus K4. This is VRG. Now again to determine K3 and K4. Now at y equal to everywhere north bank y is how much? 2L. Then VRG is 0 as specified in the problem. So 0 is equal to K3 into 2L plus K4. So this means K4 is what? Minus 2 K3L. Alright, K4 is this much. So we substitute this K4 here. So VRG becomes K3y minus 2 K3L. Now we have to determine the value of K3. At center, y becomes L. There VRG is equal to U. So U is equal to K3 into L minus 2K3 into L. That becomes minus K3L. Okay. So K3 becomes how much? Minus U by L. This becomes K3. Fine. So we substitute this K3 in this equation. VRG becomes minus U by L, y minus 2L. Okay. So this becomes U into 2 minus y by L. Alright. This second half, for the second half of the river, VRG is given by this. Here R means the velocity of river particle R whose distance from the south bank is y. Okay. So VRG is this much. So for first half VRG is this much. For second half VRG is this much. Alright, fine. Is it alright? So okay, it's alright. So complete VRG expression, we get two expressions for VRG. First half VRG is equal to Uy by L, y varying from 0 to L. For second VRG is U times 2 minus y by L, y varying from L to 2L. Is the first part of the answer. Alright, fine. Alright, here. This side of okay. Now for second part it is asked, what is the time taken by swimmer to cross the river? Okay. Now again one thing should be noted. Let t be the total time. By the swimmer to cross the river. Let t be the time taken by the swimmer to cross the river. Okay. Let t be the time taken by the swimmer to cross the river. Okay. Now see, how to find t is the question. Okay. So first of all, you must note this that see, I'll again draw the top view. This is the starting point. This is the x-axis eastward direction, y-axis along northern direction. Now swimmer is somewhere here at say at time t. Coordinates of swimmer at time t are x comma y. Coordinates of swimmer at time t are how much? X comma y. Coordinates of swimmer at time t are x comma y. Alright. This is the coordinates of swimmer at time t, x comma y. Now see, here again let r denote the river particle in contact with the swimmer at time t, whose coordinates are x comma y. Now again in this different particles of the river do not have the same flow velocity. So this river is not a rigid body, so it cannot be a reference frame. Okay. So now it is given that the velocity of swimmer with respect to the river particle in contact with it is u along northern direction. So we'll say like this, VSR in G. VSR in G meaning what? Velocity of swimmer with respect to river particle R in contact in ground frame, that is equal to VSG minus VRG. Alright. Now VSG is how much? Let us VSG denoted by V say. Okay. VRG is what? VRG expression, we have two expressions we have obtained. Why? So VRG is along eastward direction. So we write VRG is equal to VRG into I hat. And VSRG is simply the velocity of swimmer with respect to river particle in contact in ground frame. But the heading is towards north. So this is always along northern direction at a constant speed u. So this VSR becomes uj hat. Okay. So this becomes vector V is equal to VRG hat I hat plus uj hat. Alright. VRG I hat plus uj hat, that is equal to vector V. Alright, fine. This I'll rub it now, okay? So V will be written as Vxi plus Vyj hat. This is simply VSG. This is just VSG. This is VSG. V. VSG is just V. This one. So Vxi hat plus Vyj hat. That is just equal to VRG I hat plus Uj hat. If we equate the coefficient of J on both sides, then we get Vy is equal to U. But Vy is how much? Dy by dt. Just U. So dy is equal to U dt. If we integrate it, integral over U dt, 0 to t. Initially a swimmer is at origin, so y is 0. At time t it is y. Capital T is the time taken by the swimmer to cross the river. So when swimmer goes to that side, y coordinate will just be equal to 2L, width of the river. So this means this integrated we get 2L. U comes outside. Integral dt 0 to t becomes t. So t becomes 2L by u. This is one more answer. Fine. Alright. Now we have to determine the Cartesian equation of trajectory of swimmer. Cartesian equation of trajectory of swimmer. Now VRG, there are two expressions for VRG. Therefore there will be two expressions for Vx and Vy. So there will be two Cartesian equations of this trajectory of swimmer. For first half of the river and next half of the river. So we have two expressions. So to find the Cartesian equation, now we equate the coefficients of I hat on both sides. Vx becomes how much? Vrg. Alright. Vx is how much? dx by dt. Now Vrg has two expressions. This one here. Now to find this, I'll write this one. Okay. So now Vx is VRG, and first equation we have already obtained. This is common for both halves. dy by dt is equal to u. That meaning dt is equal to dy by u. And from this equation, dx by dt is equal to VRG. That meaning dt is equal to dx by VRG. These two dt's are same, so these two should also be same. dy by u barabar dx by VRG. So dx becomes VRG by u into dy. Now there are two expressions for VRG, so two expressions for dx. Now first half y lying between 0 to L. In VRG, for VRG we use this expression. Therefore we'll write dx is equal to VRG becomes uy by L upon u into what? Dy. Now u will go away. This becomes y by L into dy. So dx is equal to y by L into dy. Now I integrate it. Y dy by L. Y initial value y will be 0, x will be 0. Some instant y, x will be x. On integrating this and inserting limits, x becomes y square by 2l. This becomes x. So this is for the first half. For y 0 to line between 0 to L, x is equal to y square by 2l. For y lying between 0 to L, x is equal to y square by 2l. So x will lie in this range. Okay, this is the trajectory for first half of the journey. So this I'll rub it, okay. Now this is, you see, this is the equation of parabola. The swimmer move in a parabolic path. Okay. So if you draw the diagram for the first half of the journey, it will be something like this. This is the top view of the river. Width of the river is equal to 2L. This is the starting point. Y square equal to 2LX. Equation will be something like this. The appearance will be something like this. Y square equal to 2LX. Trajectory of equation of trajectory of first half. Y square equal to 2LX. So when swimmer comes here, x coordinate will be x1 and y coordinate will be L. Where x1 is this distance. This distance is x1. So how much x1 will be? We put y equal to L and x equal to x1. Then we get x1. So y coordinate is L, x coordinate is x1. So L square equal to 2L x1. x1 becomes L by 2. x1 becomes how much? L by 2. So this is the x coordinate of swimmer in the first half of the journey when he reaches the middle of the river. Okay. Now I'll rub this one also, okay. Now for the second half. For second half, y lying between L to 2L. Y lying between L to 2L, okay. Y lying between L to what? 2L. Y lying between L to 2L. For this second half, we use this expression in this one. So we write dx is equal to VRG by u. So u into 2 minus y by L upon y into what? dy. Okay. So now u and u will, here also there is u, no? U here also. U and u will cancel out. So this becomes, and this is, this is not y. Oh, sorry, my mistake. Alright, fine. Simply this VRG this one by u. Mistake y was written, that I rubbed it, okay. So dx means what? This is just equal to 2 dy minus y by L into dy. Okay, this dx. Fine. So dx is equal to 2 dy minus y by L into dy. Integral dx 2 dy minus y by L into dy. Alright, fine. Now what is the limit of x? Lower limit will be what? Lower limit of y will be what? L. Upper limit will be y. When y is L, then lower limit of x will be what? x1. L by 2. Upper limit will be x. Fine. So now this will be how much? X minus L by 2 will be 2 dy will be 2y. Inserting limits 2 into y minus L minus y by L dy. Y square minus L square. Okay. This is the equation of trajectory for the second half of the journey. Alright, fine. So this I'll rub it now. So if you simplify it, x becomes L by 2 plus y minus L is common. 2 plus y minus L by 2L. This is what it becomes. X becomes L by 2 plus y minus L, and this becomes how much? This becomes y minus L by 2L, and this becomes how much? 2 minus L by 2L means 1 by 3 by 2. 3 by 2 minus y by 2. This is the equation of trajectory for the second half. Alright, fine. Is it alright? This is what we get. See, x becomes what? L by 2 plus y minus L. 2 plus y plus L by 2L. Okay, this is minus here, common. So the x becomes L by 2 plus y minus L upon 2L, and this becomes how much? I'll just check the calculation here, okay? I'll just write it again. So x becomes how much? X becomes L by 2 plus, this becomes how much? Y minus L by 2L, 4L minus y, so 3L minus y. This is the equation of trajectory for second half of the journey. Okay, fine. So now rub it here. So third part, answer to third part will be what? Equation of trajectory of swimmer will be this. Cartesian equation of trajectory of swimmer. Equation of trajectory of swimmer is two equations we get. First half. Y square equal to 2Lx. X lying between what to what? Sorry, y lying between 0 to L. Y lying between 0 to L. And second half equation is what? X equal to L by 2 plus y minus L by 2L into 3L minus y. This is the equation of trajectory for the second half. That is for y lying in the region L to 2L. Okay. Y lying between L to 2L, this is the equation of trajectory. And this is the equation of trajectory for the first half. Alright. Y square equal to 2Lx, y lying between 0 to L. And x equal to this much. X equal to this much for y lying these two limits. This is the answer to the third part of the question. And lastly, we have been told to find the drift of the swimmer. To find the drift of the swimmer, so to find a drift, so when the swimmer reaches here, finally here, somewhere here, his coordinates will be, x will be just the d and y coordinate will be 2L. So to find the drift of the swimmer, let d be the drift of the swimmer. Drift of swimmer. Let d be the drift of the swimmer. So d comma 2L will satisfy this equation. So instead of x we write d. Instead of y we write 2L. Y we write 2L. 2L minus L by 2L. 3L minus 2L. So D becomes L by 2 plus, this becomes 2L minus L by 2, L 1 by 2, and this becomes L. So it becomes L. This is the required answer. This is the answer to the last part of the question. Okay. So this problem also I have demonstrated how to deal with problems, relative velocity problem, in which the flow velocity or river is not uniform everywhere but changes from location to location. This is the method to be followed. Okay, fine. I close it here.